If the ratio of diameter, length and Young's modulus of steel and copper Y. These are the two steel copper Ys. This is the steel and this is the copper. This is the steel Y and this is the copper Y. As shown in the figure are P, Q and S respectively. Okay, diameter is P and length is Q and the Young's modulus is S respectively. Then the corresponding ratio of increasing in their length would be, it is suspended by the two weights. Then there are four options is given, which is the right we need to find here. Okay, we can find the increasing in their length, that is we need to find the delta L. Delta L we can easily find here with the help of the Young's modulus. We know that Young's modulus, that is Y is equal to for stress divided by strain. That is stress divided by strain. And we know that stress is equal to force upon area and the strain is equal to change in length divided by original length. These are the notation. Okay. Then we can find here Y is equal to, this Y is equal to, we can find this one as F into L divided by A into delta L. Okay, the denominator of the denominator will go to the numerator and this A will come in the denominator. Then F into L divided by A into delta L. Then we can write this one as 4 times FL divided by pi d square into delta L. Okay, then we can substitute, that is a delta L is equal to. Then we can write a delta L is equal to, we can write this one as 4FL divided by pi into d square into Y. This is the change in length equation we will get from the given data. Then for the steel we can represent with the delta LS and for the copper it is represented as delta LC. Then we can write this one as individually, that is Fs divided by Fc in terms of ratio into Ls divided by Lc, and the new denominators will comes in the numerator, that becomes dc square up into yc divided by ds square into ys. And they are going to represent here PQS, that is a diameter in terms of P, length it is in terms of Q, and Young's modulus is in terms of S. Then by substituting those values, we are getting delta LS divided by delta LC, which is equal to, we will get that is force of the steel. Force of the steel is 2 plus 5. Fs is equal to, we will get 2 plus 5. And for the copper Fc, that is force is equal to only 5 we will get. Then I can write this one as 7 upon 5 into the diameter we can write in terms of P, that is equal to, we can write as 1 by P whole square into length we can represent it with the help of the Q, that is the Q into Young's modulus, that is 1 by S. Then if I am going to simplify, we get the value 7 times Q divided by 5 times P square into S. This is the ratio of delta LS divided by delta LC. This we can see in the option number 2. 7Q divided by 5SP square, 7Q divided by 5P square S. Both are same here. So option 2 is the right answer.